Hello and welcome to the Big Data and AI webinar series, where we are committed to bringing educational content to the space, where we also bring together speakers and vendors to discuss strategies, solutions, and emerging technologies. Today, joining us, we have Mike Carey from Neo4j, and he will be exploring how graph databases are transforming the modern enterprise and powering intelligent real-time business application. He'll be showing us the Neo4j's Graph Platform and explain at a high level the advantages of implementing such graph databases, and also be showing us some examples on how to use it. Neo4j is one of our sponsors at the upcoming Big Data and AI conference taking place on September 29th and 30th. So make sure if you're joining the conference, attending the conference, make sure to check out their demos, their conference sessions, and as well as to go and visit their booth. For more information and to register for the conference, visit bigdata-toronto.com. So for today's sessions, if you have any questions, please input them into the Q&A tab located at the right-hand side of the screen. All questions will be answered by Mike at the end of the session. This session will be recorded, and a link for the session will be distributed to all registrants after the webinar has concluded. Now I'd like to pass things over to Mike Carey. Mike, how are you doing today?
Doing great. Thanks for having me.
No problem. Thanks so much for joining us today. We're super excited to have you.
Yep, super excited to be here. Let me go ahead and share my screen. And okay, here we go. Okay, so thanks everybody for joining today. So I'm Mike Carey. I cover all of our commercial activity in Eastern Canada for Neo4j. I also work with all of our accounts up there, and super excited to talk about graph databases. So I'm not sure folks on the line are familiar with graph databases or new to graph databases, but hopefully I'll give you some insights into what they are, how they can be used, and then how to learn more at the upcoming conference. So just a little bit about the company before we dive in. So Neo4j has been around about 10 years, and the company was founded on the premise of trying to solve the problem that there's all these relationships and connections that exist in data, and that relational databases did a poor job of handling all of those relationships and connections. So the company was founded with that in 2010, and we've grown to be a pretty formidable company over the last 10 years. So we've got thousands of customers worldwide using us for both operational and analytical use cases, as well as our language that we built the platform on is now becoming a new ISO standard, really the first ISO standard since SQL, now called GQL, which will be rolling out over the next few years. So there's a ton of momentum across the industry for graphs. We've got lots of both large and small and startups using our platform, as well as the ability to use that platform any way that fits you, whether that's on-premise, in the cloud, or database as a service. So it talked a little bit about 2010 when the company was founded. This was really when special purpose databases were becoming more and more relevant for enterprises to use. So you can see on the left, there's a site called DB Engines. DB Engines goes out and ranks trends in the database industry. So you can see that graph is that green line, that the popularity of graph databases has grown over 1,000% and is the fastest growing category in that database category amongst XML databases and document databases. And then Neo4j is the most popular graph database within that category, and you can see pretty well above some of the other technologies in the graph space. And that's really due to both the innovation of Neo4j as well as the deep community. So over 220,000 developers worldwide that know Neo4j. So in addition to sort of the community, we also have the analyst community rallying around graph technology. So you can see, Gartner more and more recognizing the fact that the graph data model, the ability to model connections and relationships, maps really well to a lot of real world conditions that relational databases do a poor job of. And that foundation of handling, storing, retrieving those connections is giving companies a whole new platform for advanced analytics. So it's becoming a much more critical part of more and more companies' advanced analytics platforms. And again, due to the innovation that's been happening within the space as well as specific to our company. So when you think about the connections that exist, right, there's connections in data all around us, right? So you could think about networks of people, right? Other people, you're friends with people, and you can see this started to manifest itself with both social networks as well as professional networks. So you can think about Facebook and LinkedIn as graphs, right? You know people, you like companies, and you can start to see what's the shortest path between me and this, maybe the CEO of a company, that there might be two hops or two people in between that can get you an introduction into that company. So you've got networks of people, you have transactional networks. So things like, Amazon e-commerce kind of pioneered this, right? With giving you relevant recommendations. So if you're going to look at a certain product, what are other people that looked at that product also buying? Or what are other relevant products linked to that? So these connections have become more and more important as companies try to tap into that data and the insights that they bring. And so there was a book written by James Fowler that kind of hones in on this and talks a lot about, connections and relationships are really the strongest predictors of behavior, and that you can make better predictions by understanding the connections between people than you can just about knowing something about that person. The example used in the book is trying to understand if somebody is a smoker or not. So you could have the data about the person, their name, their address, their age, where they live, and that would give you some predictor. But a much more accurate predictor would be understanding who they're connected to and whether those people smoke. So by understanding those connections, it's a much more predictive way of doing those analytics. And so you already have this data. So most organizations have this data, right? It's just that the current data models, like on the left here, ignore the network structure that you see on the right-hand side of the screen. So these graphs add these highly predictive features to your machine learning models. They increase the accuracy, and they can give you these better predictions that you just can't get without understanding that network structure of your data. So the data exists. The graph technology allows you to kind of take that, create a model around it, and then either use that in an operational type of use case or an analytical or algorithmic type of use case. So graphs have become a very natural way for both types of users, developers, data scientists, to be able to tap into those data and provide better insights. So you might be able to, we have lots of customers pulling data from many different sources, like you see on the right here. So you may be trying to build maybe a holistic view of your customers. So maybe you're trying to build what's commonly known as a customer 360 type of application. So you might want to pull together data from your CRM system, data from their online behavior, other types of customer data, maybe in a data warehouse, and the ability to pull that all together and make the connections between the data is what Neo4j and graph technologies allow you to do, to move from those disparate silos into connected data. And so graph is, just a great way to do that. So, we kind of contrast approaches for trying to solve that problem. So, right, relational databases are obviously built to store and retrieve data and do that, better than anything else. NoSQL databases are great at aggregating and filtering large sets of data, but Neo4j is squarely focused on applications that need that connected data type use. So you might be thinking, okay, what does a graph look like? So a graph is not based on an XY coordinate graph. It's not graphical database. It is based on the property graph. So for any math folks out there, you'll know about property graphs. But you can think of a graph model is built on nodes and relationships. So nodes are the objects in the graph, and obviously relationships make the connections between those objects. So here's a real simple example of you have person nodes and you have car nodes, and then you have the relationships that describe how those are connected. So, Dan is the label of that person. He's married to Anne. Anne owns the car, Dan drives the car, and then you have attributes on both the relationships as well as the nodes. So you can see that Dan drives the car since a certain date. Dan has a Twitter handle, whereas Anne doesn't. So we talk about the other component of this is it's schema optional. So you can enforce the schema, but you can also have schema optional optionality within your model. So this forms the foundation of the graph model. So we typically go through a modeling exercise with organizations to help build this out and think about the data in graphs versus rows and columns that you might be thinking about it today. So just some sample queries to get you thinking about how this would work in a real life scenario. So you can think about a typical fraud example within a financial services company where you're able to build out a graph of the account holder, the accounts that they have, other information about that account holder, as well as maybe their IP address that they're coming in from, their social security number or ID number. So all of these form the foundation of a graph, as well as connecting between different account holders. So you can start to run queries that identify potentially fraud rings. So you might run a query that says, how many flagged accounts are in this account holder's network 4 hops out to get you to other accounts that they may have a connection to? Or how many shared login variables are in common? So are there 2 account holders that maybe are sharing an ID number or sharing an IP address? That might be a potential flag for a fraudulent account. So this gives financial services companies a whole new set of tools in order to be able to arm themselves against financial fraud, anti-money laundering, credit card fraud, etc. In the drug discovery process, we've got organizations like Novartis and the Zuckerberg Foundation leveraging knowledge graphs in order to be able to mine research for new insights, right? So in that world, they're trying to understand what are the connections between genes and diseases and targets, and are there some connections that we didn't think about that might lead to a new drug discovery, right? So what genes could be reached 4 hops out from a known drug target? Being able to understand connections between 2 drugs. So this is giving pharmaceutical companies and other research foundations whole new ways to do drug discovery. And then, marketing, we're used to this type of product recommendations and like Netflix recommendations that's recommending what they think would be most important to us based on some type of collaborative filtering and other algorithms. So other users who bought that product also bought these products. But by using a graph, you can really build this out in a more complex way. So rather than a very simplistic, here's other products that those people bought, you can get very fine grained. So you can think about maybe it's you're looking for sushi restaurants in Toronto. Well, with a graph, you could say, show me all sushi restaurants in Toronto that my friends like, that have a rating over 10, that have a gluten-free menu, and really get into this whole multi-hop type query to drive a much more much more accurate result that customer can then get. So this is being used more and more from a marketing standpoint. So I talked about some of the use cases, but these are some of the most common applications of Graph today. So real-time recommendations, like those product recommendations, movie recommendations, fraud detection. We were actually used in the Panama Papers to uncover a lot of the offshore fraud that was happening across the globe. So there's actually a movie on Netflix all around the Panama Papers. So that actually used Neo4j as a technology to help those journalists uncover that. But lots of financial services companies using us in the fraud detection area. Network and IT operations, you can think about a company's network as a graph and trying to understand both security vulnerabilities, how attackers might try to get to crown jewels within your network, as good use cases of graph technology. Master data management and understanding how data flows throughout a company. Knowledge graphs we talked about, and then identity and access management, trying to build a graph of what individuals from what organizations have access to what systems, especially from a customer facing side that can get very complex. So we've got lots of companies using us in that identity and access management area as well. So hopefully that gave you an introduction into graphs. Hopefully you're excited to learn more. So here's some ways that you can get even more oriented to graph databases. So we just released, we're super excited about this, our Graph Database for Dummies book. It's a great way to get introduced to graph databases. If you come by our booth or attend any of our sessions, we will send you a complimentary copy of this book. And it's just going to be a great way, if you're new to graphs, to be able to explore how to work with graphs, as well as how they can be applied at your organizations. We do have some sessions as well as demos at the show. So on September 30th, we're jointly presenting with one of our customers, BMO, Bank of Montreal. And that session is focused on their use of Neo4j for a knowledge graph. And I don't want to kind of take away the thunder there, but that'll be a great session done by our customer, Paulo, who will speak at that. And then we have two product demos, one focused on graph data science and all of the algorithms that you can use within Neo4j. And then the second one on how Neo4j can be applied specifically for cybersecurity use case. So those are both as well, 29th and 30th. We also have a booth, virtual booth here. So, definitely stop by. We'll be available to chat, answer questions. You can book a one-on-one meeting with us via the conference app. Happy to discuss specific use cases, answer questions. And we're giving away some cool prizes. And of course, you can contact me anytime. Here's my contact information. And I really look forward to hopefully discussing with you and answering any questions right now. Thanks.
Awesome. Thank you so much, Mike. That was fantastic. We really appreciate you being here with us today. Doesn't look like we have any questions right now. But again, for anyone who might have a question that comes up later, even if you aren't registered for the conference, although we definitely do recommend that, you can attend the conference and watch Neo4j's demos and go to their booth with a free ticket pass to attend those. So if you have any questions, Mike did
question. So I do see a private chat from.
Oh, someone sent you a private one. Okay.
Yeah. So let me read this off here. Does Graph Database sit on top of an existing database engine like SQL, Oracle, or is it a replacement? if the former is the answer that it requires making changes to the structure of the tables and relations. So let me answer that. So yeah, graph databases do not sit on top of an existing database. We are the database. So we have everything you'd expect from a database built into Neo4j. So we are an enterprise class database. And typically what happens is you're loading data from other systems into Neo4j. So we have multiple ways of loading data or connecting to Kafka streams to get data into Neo4j in order to be able to take advantage of the graph structure and the query language that we use. So yes, you do have to make changes. You don't have to make changes to the original structure of the tables. What you need to do is make the connections between the different pieces of data that exist. And there's great examples in our documentation as well as on our website about how to enable all of that.
Awesome. Amazing. Thanks so much.
Yeah.
So thank you everyone so much for attending. Again, Mike, thank you so much for being here. We're super excited to see you and your team at the upcoming conference. Again, all of Mike's demos and presentations that Neo4j is having, go see them at their booth. And thank you again for attending, everybody. And okay, we did have one more question come in. So we'll handle this one question and then we'll let everyone go. Mike, does Neo4j have algorithms such as discovering cliques embedded?
I'm not sure what that means. I don't know if you can provide some more context. I'm not sure what cliques embedded means. So Krishna, I don't know if you can provide a little bit more context for that.
Just wait a couple seconds, see if they update their question.
Oh, connected. So everyone is to discover if everyone is connected. So there's about 50 algorithms in Neo4j. So we have community detection algorithms. There's Louvain algorithms. There's shortest path algorithms. There's PageRank algorithms. So on our site, we have got a list of all of the algorithms, but as if you're looking for like connected component algorithms, those do exist in Neo4j.
Awesome. Again, thank you so much, everybody. We look forward to seeing you all hopefully at our 5th annual Big Data and AI Toronto Conference, September 29th and 30th. And if you would like to learn more about the conference or register to attend, visit bigdata-toronto.com. Thank you so much, everyone. And Mike, thank you again. Pleasure to have you.
Sure. Thanks, everybody. Bye.